My name is Alex Thissen, and I'm a cloud architect from the Netherlands. This is my second time in Moscow. Was here last year. Did a session on .NET Core actually, and containers in St. Petersburg. And today we're going to talk about serverless architectures. Now, who of you has investigated a bit in serverless architectures? Nobody yet? Okay, so the good thing is we're going to talk about what it actually means to have a serverless architecture. We'll introduce Azure Functions, and we'll learn how to program Azure Functions and what makes it a bit different from the other ways to program with serverless scenarios. We'll do a bit of debugging, testing, and finally the last bit will be about how will you host your application, your functions in production. So, serverless architectures, what is that all about? Well, there's a big trend now, the Docker containers, which is about having clusters of hosts that host all your applications inside of containers. And some people say that the next thing is that you're actually not concerned about servers anymore. So you don't have a cluster of machines. You don't have any servers at all. So that's a bit strange, right? Because how can you run something if there are no servers? So the serverless is maybe a bit more about you have to think about servers less. They're there when you need them. So it's not empty rooms. There's compute for you, but it's only there available for you when you actually need it. So think about a scenario where you have an application that's running on this big cluster, a couple of nodes, a couple of machines, and it's running all day and it's only processing some time because there's incoming messages, or maybe 1,000 messages a day, and how much would that cost you? Well, in a container cluster scenario or running your own virtual machines, it would cost you whatever the machines are spinning. If you don't have them, but only pay for what you're actually using, then it might be from a perspective of cost, it might be very efficient. So where containers, you're already building all these autonomous small systems. Functions is what they call, or functions as a service, is a way to build small pieces of logic that's all self-contained, that's very dedicated, is triggered by something happening around it. So it can be an incoming message on a bus, or maybe an HTTP request. Maybe there's something on an event grid, something new from Azure that's coming in, there's something happening, and the function reacts to it. And it executes this bit of server-side logic, and then it's done. And if there are a lot of requests come in, what the serverless architectures typically do is that they'll just scale out instantly as soon as it's needed. So if there's a high peak, because there's something happening, like a big tweet happening, and there's all these messages coming in, you'll go from just a little bit of compute to a lot of compute, and it goes away again. And usually the model of paying is sub-seconds. So you're actually paying for sometimes every microsecond that you execute. But if you're not doing anything because nothing is triggering your functions, then it doesn't cost you anything. This serverless pattern, there's a lot of things that you can consider serverless because not everything is regarding servers. But the fact where it involves functions is offered by a lot of cloud providers already. Amazon with AWS was the first. They introduced Lambda, which is also functions. Then Azure and Google Cloud came with their version of functions. And there's even new competitors entering the market, such as Auth0, who entered the space from identity and access management, but they're now also doing something that's called WebTask.io, allowing you to build the same functions and have a serverless way of hosting your logic. So there's a lot of things in Azure, and we'll be focusing on a particular piece of it, the Azure Functions. And their model is that you will have code, various types of code. You will have events, and the events, they give you some data to work with, or you can actually receive some additional data, and that's what you're doing. So it's processing events, and you're writing code that's executed at the server. And there's all these scenarios of what you can actually build with something like that, something happening. So it could be time happening, like every hour you will execute a bit of code to clean your logs or your tables with some SQL function that you execute. There's even scenarios where you can bind to something like the Office graph, where you can do Office 365 things like Excel sheets that are being uploaded or changed, and then act accordingly, send out mails. And this is another scenario where somebody has a phone, takes a picture with his app and uploads it and executes a webhook. So that's a trigger over HTTP. And your function, your first function could receive the incoming input stream with the photo and store that into blob storage. So it's safely tucked away. And then it will pass it on by executing another event to another function that will take the original picture and just scale it to different sizes, small, medium, large, and put that into other blob storages or send it out or whatever you think is necessary for your application. And these are all isolated pieces and they can scale individually. So they can just scale in and out whenever it's needed. And it's dedicated, so one is accepting and storing and the other one is scaling. And this was typical for a topology with serverless architectures where you have many small functions doing one thing very well, sort of like microservices, and they will compose an entire application. So what is an application that is built around Azure Functions? What does it look like? It's a function app. If you look under the covers, it's an app service in Azure. It's a web app, and it has a couple of JSON files that specify how it should be hosting. And the main part, and the most important part, is the functions that are in there. So there's potentially multiple functions running inside of a single function app. And each of those functions has a particular trigger inside of it. And the trigger is an indication that the code needs to run, and it will consume input that you might have or might not have. So in this case, it could be the incoming photograph that we just saw, and it will output whatever is needed, but it might not output anything. So 0 more things. You can have multiple functions, and each function can have its own trigger and its own inputs. So it doesn't have to be the same for every function that is inside of your app. Some other things that are interesting, most of the Azure Function things and implementation are open source. You can find it on GitHub. There's many languages that you can use to actually program your functions. We'll be focusing on C# and .NET, but if you pick your flavor, there's an increasing list of things that is out there. Another nice thing to know when you start processing it, and it helps you build your architectures, is that they have a limited time of execution. So you have all the compute that you can need, will ever need, but it's only allowed to run for 5 minutes by default. So you shouldn't be doing long-running tasks. It should be short, nice, sweet things, and otherwise you'll need to split them up and separate responsibilities. Or come talk to me afterwards in the discussion zone, and I'll explain how you can do like processing millions of records, how you would typically do that, because that will probably take you more than 5 minutes. They build on top of Azure Web Jobs, and they build this nice layering where they use the app service as a basis. Then they build the Web Jobs core and their extensions. And the extensions are particularly interesting because they have all the triggers, inputs, and outputs that you will be using inside of your functions. So they actually come from the Web Jobs. And whenever there's new things involved in Azure Web Jobs, you will benefit from it in your functions. Because on top of it, Microsoft has developed this script runtime for web jobs, in particular, the language runtimes that work with it, and then finally your coding configuration where you write your function. And that altogether allows you to write your function implementation via script, or in a more robust way using C#, assemblies, and not using dynamic compilation. So that's the two flavors that we have. The first one is using scripts. Scripts are all the languages like C# script, maybe something like Node.js and JavaScript. which allows you to get instant feedback. You can change your code, it's there, it will be dynamically compiled, and it will just make sure that your application is running there and has the new implementation. It integrates well with all sorts of source control, so you can actually tie to commits on Git or GitHub, whichever thing you have, and it will get the latest commits, put it there, dynamically compile it, and start running it. So it's a very fast feedback loop, maybe ideal for testing scenarios. But if you want to achieve higher code quality, you would go to option number 2, which is .NET, and you will write C# code. You will do it from Visual Studio typically. And you can do all the things that you would normally do inside of your development with C# in Visual Studio. So that means that you have your compilation, which with all the compile errors, your feedback, your code analysis. You can do unit tests. You can have all other types of code coverage, and even your build pipelines to make sure that whatever you're building, and when it reaches production, you know about the quality of your code. And it's repeatable. And it's just like any other type of development that you're probably doing if you're doing ASP.NET or other .NET development. So let's see if we can make that work in a demo. So what I'll do, I'll quickly show you how you would do a new function. So let's do a function app. And you'll create a function app. You'll give it a name. So .NET Functions Live. You can use, you need to put it inside of a resource group. I'm assuming here that you've seen a bit of Azure before this. So let's put that in this, this existing one. This is one I'll mention, the hosting plan. There's the consumption plan, which is the one that charges you by the sub-second. So whatever compute you need, it's charged based on milliseconds. But you can actually also do the app service plan, which is the original plan, and then you're just paying a set fee, but you have a set capacity ready for you, waiting for you. So it's like you already have some scale, and it can increase, or you can have almost zero scale, and it increases when it's necessary. So this is good for testing. The other one might be great if you want to do predictable load and scale. So we'll put it in West Europe. Let's create a new one. There's the application insights that you can turn on. And now we'll actually create this, this function. It will create storage underneath because some things have to be stored. It will work with that, but I've already prepared one. So let's go to that. This is what you'll end up with. You have your environment, and maybe I can bump it a little bit. Like so. The way you look at your functions, it's just a list that is there. Maybe we need to wait for the other one. Yep. So the reason that we can't use this one is that this one is read-only, and I'll explain that later on. We'll wait for this one, but we can look at one of the functions. So I'll show more bits in a second, and we'll do this HTTP trigger. Okay, there we go. This is your C# script that is there, and this is your function. You can actually program each of these, and this function here, let's just run it first. So you'll get this nice test utility on the side where you can just put in some values for your request, and I put in there hello the name .next Moscow, and we can run it. And if we look down, you can see that it actually gave a status of 200 and a return message. Let's like that. Just a second. Sorry about that. There we go. And there's also a log indicating that the function has triggered. Okay, so how do we get there? And I see that the other one has arrived, so we should have a new one. This is the functions live. Now everything is enabled because we haven't deployed to this yet. And let's see what it takes to build such a function from here. So you can actually, usually you get the quick start menu where you can choose whichever language you want to do. You have some scenarios, but if you go for the custom functions, you'll end up with this list. We'll pick C#, and there's quite a number of samples here that you can use as a jump start. The one that we just did is this one, the hello, the HTTP trigger one. And we'll create that one. And this is where you get the same experience, but now this is editable. So this is your starting point, and you can work with this code, discover all the things. You can actually see what's behind all this. So there's this run CSX, that's the script file, and there's also a function.js, which is this one. It's a function describing, a JSON file describing what's in your functions regarding the inputs, the outputs, and the triggers. The default UI is this one. So you can define your triggers, your inputs, and your outputs. And in this case, we're getting an HTTP input, and we're outputting HTTP as well. This is where you configure it, and this is just a nice UI over a JSON file. But remember this one, because the function JSON is there for every function, and it describes what goes in and what goes out. You can't really tell here. Well, in this case, you might be able to do a little bit of it. You'll see this run function. This run function is the heart of your function. So it's a static method, and it receives some input, which is the HTTP request message. It also has by default a log file, a log object that you can write to, and it outputs something. And in this case, it's a task, so it's an async method as well. And then there's just your logic and producing the output, which is in this case creating a response, which is the return type. So that's your output in this case. This is the easy scenario. Just you get a trigger. It's defined in your function JSON. It says here that the rec, which is the parameter name, is of type HTTP trigger. It goes in, and then your return type with this special notation here of $return is an indication that your return type will output HTTP. So that's what you work with. There's more to be said for these things. So there's a lot of configuration that you can do. So if you go to your function and the overview for the platform features, you can see that this is all built on top of Azure Web Jobs. So there's a couple of things, for example, Resource Explorer, where you can drill down underneath and see what's under the covers. You might not go there very often, but there's like this entire tree of where your application actually lives. If you want to manage that, you can actually also go to the advanced tools with Kudu, and that allows you to interact with the runtime underneath. There's even a debug console where you can do a command prompt from inside of your browser, allowing you to interact with the file system, with everything that's running there. So there's functions is a nice abstraction, but if you need to reach down, you can actually go underneath. And this is all there for the use. There's other things that might be specific for your application. For example, you could generate Swagger documentation, because in some cases you're using, like this, in this case, HTTP, which resembles a web API. And this gives you this documentation. Let's see if this works. Gives you the documentation, and it's generated. It's in preview, so there might be issues with it, as we might have now. Sometimes it switches back to the revert to the last saved, but it might not now. Okay, final thing is, if we go back to here, then there's also core support. So you can have the cross-origin resource sharing, which allows you to circumvent any issues that you might have reaching HTTP functions. So a lot of things from the platform. What it boils down to is, how do you build your functions? And we can do them if we just go here. you can type them here, but that's not like something that you can share with your team. Where do you leave your source code? How do you version this? So that's what we're focusing on next. So developing those functions using .NET, which that was C# code, but with Visual Studio. And to get you started, what you do is you install Visual Studio 2015, 2017, but the 15.3 or later version, and pick the Azure workload, because that will give you all of the Azure tooling. Then you will also install the Azure Functions, which is a separate package. You might install .NET Core 2.0. It's therefore required, but it will be in a time. You will be developing for .NET 4.6.1 at first. And you will install the function core tools, which has this, this command line interface. You might do Azure Storage Explorer and Postman, because those are tools that might come in handy. And we'll cover those in a second as well. The command line interface is there for you. It has a lot of functionality that you can use to build and run your functions, manage them, to publish them to Azure. And it's also used by Visual Studio. So Visual Studio will use this command line to host your applications on your machine. So you will see this small ASCII art logo for Azure Functions. You will see that popping up quite a number of times. So back to the anatomy of a function. What is a function? How does that work? So first of all, there's always a trigger. The trigger, we mentioned some of them, service bus, maybe a blob that goes into blob storage, or time passing. There's all these triggers that you can have, and you can have additional input bindings, which is more input. Those will appear in your function as input parameters. And the output that is there's two scenarios. You can have the return value like we saw in the HTTP, but you can also have output that is going to blob storage, to Azure Table Storage. So multiple outputs for you to produce the things that you need in your function. So this is the high over one. If you look at your code, we saw the run method just a moment ago, which was a run which received an HTTP request. But in this piece of code, there's a couple of additional things. So first of all, your function needs a name, and the name is provided by an attribute. So just an attribute decorating your run method indicates that this is an Azure function. Then you have your HTTP trigger. The attribute at the beginning says this is a trigger, because when you're programming in Visual Studio, you don't have the function JSON file. So you're not building or editing the function JSON yourself. You'll have the tooling do that for you. But this is your way to indicate what needs to be in that file. And then for your output value, HTTP response message, since this is a clearly well-defined output, this will just work. So you don't need to have anything special there. That's only if you have one output. Then you can use the return value. Now let's make it a little bit more difficult. If you're receiving more input, and if you're actually outputting something that's a little bit different, take a look at this one. So first of all, you have, in this case, a queue trigger, which means that something got put into an Azure queue. The queue itself is called images to analyze, so that indicates where it should be going. And you have a connection there inside of the attribute that says, where is this queue located? So which subscription in Azure, where is it actually? And you'll define that in a separate file. And then you have string image name. So what happens here is that since you indicated that you want to receive input from your trigger, it's a message on a queue, and you say it's a string. So if the content of the message on the queue is actually a string, it will be put inside of image name. Otherwise, it will error out. But you'll probably know what to expect on a queue where some application is putting something, like the name of something, and you can use that. And in this case, it expects that what you put in the queue in the message is the name of a blob that has arrived. So think about the example with the phone uploading a photo. The first one puts it into blob storage, and the second one, this could be the second one, where the first one says, okay, I'll put something in blob storage and I'll put a message on the queue. The message on the queue contains the name of the image in the blob storage. So the second one is the blob over there. It says, okay, we'll have some input. It's in a blob. It's not a trigger, but just a blob. And it's inside of images. And the name of the blob is called whatever was given in the Q trigger. So the image name. So it's actually a replacement of what arrives in image name. And that's a nice way where you can just define things arriving from your trigger, they go into your input, and you bind it all together. And it's all taken care of for you. So that's the beauty of functions, that you don't have to know how to listen to a queue, how to get data from it. It just works. That's the bindings that we saw in the web jobs extensions. Okay. Now the other one is the return dump is now a string, and we're outputting something, but where should the string go? And because this is not clearly and well defined, like HTTP response message, you need to decorate it with an additional attribute. In this case, you're telling it, so the return type, it's a string, but the string needs to be put into a message and put onto the queue that's called analysis result. And the connection tells you where it should go. So this is your way of programming. It's defining metadata inside of your function run. And there's this list. This is not even a complete list, but it doesn't matter what's all there, but there's like a lot of things that can act as a trigger, can act as an input, and allow it to be used as an output. And this list will grow. Some things like event grid are not even on here, but that's the Microsoft's new offering for a large event-based grid. Ideal for these scenarios, because you can just listen to events popping up somewhere and act with your functionality. So, diving into Visual Studio. So what I did here is I installed all the tooling. I created a new project. The project is of the type of an Azure Functions project. So you will actually go to Cloud, pick Azure Functions, and create a function there. This template will be available if you install the extensions for Visual Studio. And after you've done that, it will create an empty solution with a project. And the project doesn't contain anything except for your host JSON, which is empty, and usually stays empty unless you want to configure things. And it has a local settings file, which are settings that are only apply for you on your local machine. And then you can build your own first function. I created sort of an hello world-ish function. It's almost what we saw on the slides. So there's an HTTP trigger defined for this request. It's incoming, and we output an HTTP response message. And instead of just copying it, the hello world and just saying names, I actually look at the headers inside of the request, append them all together, and then I will output them in the response. So I'll say, okay, this is an okay. There's hardly anything that can go wrong here, but you might need to want to do some error handling. And let's see what happens if we run this method. So I press F5. It will spin up the local hosting. So this is what it says. It loads some extensions, and then it starts scanning for all the run methods, and it found 4. And we'll be looking at this dump header function first. Because that's an HTTP one, you will actually get a nice URL over there that you can use. So we can go to a browser. If you go to the location where your application is hosted, so 7071 by default, you can actually tell if your application is running okay. And if you go for the dump headers and look at what is there, let's bump this a little bit, you can see what headers were in there, just as an hello world-ish example, but you see that there's more to it because apparently a lot of things arrive inside of the headers. But you can expect the incoming request. Just like this. Okay, the other one is this high score function. I like video games, so usually theme some of the examples with that. Just to go through some of the things that you can do with the bindings that might be a bit different from what I showed in the slides. The implementation is pretty trivial, so in this case, it's an HTTP request that comes in. It has a payload, the body that contains the score for a person. I've specified that the route on which it arrives is API/high-scores-player, and then I've used a name pattern. So this nickname thing with the curlies means that it will be available to you in this string. So the binding will take care of extracting from the URL whatever you put after player that will be given to you in this string, and you can work with that. So when composing the final message, I can actually use that value and say, okay, you have scored so many points, and the points are written from the request, the content, and in this case, we want to do an async method, and as a best practice, also do an async implementation. So now we're maturing things here. Whatever you put here is up to you. So you can use your imagination of what you would like to do doing this. So we can go to our URL again. Here's the URL. And you'll find that if you put this into here, it will actually not work. Yeah, sorry. Player/Alex360, that's my nickname. This couldn't be found. Are we still running? Okay. Not sure what's going on there. Let's skip this. I might try this.
Are you using players? Are you typing players or player?
I just copied it, but I might have a typo here. What did we do in the... so it should be okay. But let's try something here, because it would not have worked anyway, because it's specified to be a post. It only allows post, because I'm posting body content. So if you try that in your browser, you would actually get that the runtime would say get methods are not allowed, because it's not specified as one of the allowed methods. And you need to go to another tool. You can use curl or Postman, SoapUI, whatever the tool of your choice is. And you should be able to do a post. The post needs some headers. So in this case, there's actually a content type of application, and it should be not this one, but application/JSON, because we're uploading JSON. And in your body, you would put your score, and then it didn't work just a moment ago, but now apparently it is working. So we can just even step through this, read the code. So there we have the score. Yeah, it's the right score, and we can output whatever is there. You will find the result of this in the logs that are output. So it says here, state is okay, that's the request ID, the function has completed successfully, and here we can actually see that in the body, DotNext achieved the score of lead. So it's kind of working, and this is your flow of how you would test your functions. The final one that I would like to show you now is this one, the QR code generator. Which uses yet another couple of things. So in this case, we have the run method that is located here. It's async. It doesn't return something by return type, so we need to use output bindings, because what we want to do is we want to accept a message on the queue with some text and generate a QR code. You know, those blocky kind of QR codes. So I imported a library for that, and this is the meat of the implementation of generating the code. But I need to get the text that is inside of the queue message, which is this one. I've specified that it's using this connection .next queues, and we can find that because that is something you have to define. This is the .next queues. It's inside of the values of your local settings file. And I've given it this weird connection string. Normally it's something like the connection to your Azure storage space. But now I've used development storage, which allows you to dig onto your system in the storage emulator, which behaves just like Azure. So you can do your hosting locally, and you don't need Azure connectivity. With that, we're telling it that it should be in this QR codes request. That's the name of the queue. And whenever when we generated the QR code, we're actually going to write to a blob object because we want to generate the image and put it into blob storage. So this argument that is in the argument list of the run function is of type cloud blob. It can be other types, so if you are just outputting text, it can be a string as well. The runtime will take care of that. This is the name of your connection, and we want to have file access that is read-write because we want to write into it in this case. And we're using this blob container, and then there's this other special thing that says, generate me a random GUID. So it will automatically give it a unique name so you can just write to it and don't have to care about creating the actual blob object. So you'll just open it to write async and then just save the bitmap as a PNG into the stream that you've opened from the blob object. So receiving and outputting, and this might be typical for your implementation if you're not doing much logic. This is a function. Think of something like a registration system. Somebody is registered. They need to have their own special QR code generated, and this will take care of it. And you can use it inside of your web application, for example, to show it in a web page. Now let's see if we can run this as well. I need to go to the Storage Explorer, which is one of the tools that I mentioned. It's a bit smallish, but this is my local one right here. Development is what it says. I have the queues there, and I will pick out the queue. That's the QR code request. I can just say .next Moscow 2017. There we go. So this will generate this message in the queue. And if all goes well, this will be picked up by our locally running instance. We might refresh it, and after it's picked up, sometimes it takes a while, then it will generate a QR code for us. In the meantime, while we're waiting anyway, there's a breakpoint, so as soon as it gets picked up, it will hit the breakpoint, if all goes well. You can do the similar thing to if you're running on Azure, because the Storage Explorer also allows you to go to your online things. So if you look here, there's also an Azure subscription that I have with blob containers and queues, and I created the same ones there. So you can also do it for real in the other application. Well, nothing's happening now. The result would have been, let me show you that. That it would actually generate something like this. A QR code. Let's leave it running and hope that it pops in a while. Okay, so there we go to this one. So what we saw that is there's a lot of nice things that you can do with the input and output bindings with the triggers that offer information. And it even goes a bit further because we use this queue trigger thing, which is a metadata regarding the queue trigger in this case, giving you a string content of your message in case it is a string content. But if you look at the right at the green square, it actually shows you that to a queue trigger, there's even more things there. So there's a DQ count, for example, which goes from 1 to 5. There will be 5 retries, and then it's put into this poison queue, so it doesn't keep running your functions. And there's more things to be found regarding the details of your functions. And you can use them in the curlies if that's necessary, or you can inspect them from your metadata in your code. Then the other thing, because why do we put all the things there? Don't read the things inside of the big red square, but that's just the attributes that we put on our run method. We have the function name, which generates this folder inside of your deployment location for your function. One folder per function, and inside of it will be one function.js file, which will be generated based upon whatever metadata is there. And this is all taken care of by the .NET Functions SDK. It's a NuGet package. It's a meta package referring to other NuGet packages that you will need. but it will make sure that this is actually executed, and it will put publishable output content inside of your bin debug folder. So you see that there's a net 461 on the right. It contains the host JSON, it contains each of your functions with the JSON files, and it has the bin folder with all of the binaries, all the assemblies. We already saw some of the debugging, and let's hope that the other one will find its way. In Visual Studio 2017 or code, it's just a matter of pressing F5 to start your debugger. That's all quite easy. If you're using Visual Studio Code, expect it to be more on the Node.js side of things and debugging those things. But you can also do it from the command line interface and start your host there, which is something I have prepared. I'll stop this one and give up on the item arriving. And we'll go to here. So I'm now into the bin debug folder net461. There's the function runtime. It gives you a lot of options of what you would like to do. Work with your Azure subscription, about the hosting, which we'll use in a second, but also with templates to generate functions as text files, template files, so you can start working with them. In this case, we'll do func host, and we'll start the host. This is if you are present, and I will just start the hosting. But if I do -- debug and then VS or VS Code, in this case VS for Visual Studio, it will start the host like it just did, and it will pop up this just-in-time debugger dialog where you can actually connect to your Visual Studio containing the code, and you can start debugging from there. Now, why would you do this? Because it seems like pressing F5 is almost the same thing. Well, if you go to func host and then just press enter, you can actually see that there's things that you can specify that will not be specified by Visual Studio. So you can have different timeouts. You can use HTTPS, which will generate a certificate for you, so you can listen to secure communication, a different port if that somehow needs to be done, and you can specify your course things for running locally. So this allows you to tweak your hosting a little bit. There are options for remote debugging. So inside of the Azure portal, you can switch on the remote debugging, pick your Visual Studio version, and you can actually reach out and attach your debugger to a running instance on Azure, which is kind of a complicated thing because there's multiple machines running, because your application might be scaled, and so there might be more hosts of doing the work, and they need to find the actual one where they need to attach and put all the other ones at pause. So something that you would be mindful about if you want to debug in production, but it is possible. We saw most of the testing that I did, because if you run them, you would like to exercise them and try to see how they behave, and sometimes they don't behave. But do know that there's also this special administrative endpoints that you can use locally that are /admin, then the function with your function name behind it. So if you go to that endpoint, you don't have to use queues or blobs. You can just call that thing and pass it some JSON representing what would have been in the queue, for example. This will be kind of hard to do with binary content, but if it's just parsable JSON, then you can put it into the post. And it's only for post, so it requires a post message. Not for every scenario, but it might come in useful. The other thing that you can do is just do the unit testing. I'm pretty sure that you want to test your applications as much as possible and do it on a regular basis, automate it. The usual things apply. So get out of much of your dependencies as possible, put them separately. It's hard to use dependency injection in a version of control container here because, you know, it's a static run method, so it's kind of hard to inject something, but you can use the service locator pattern, which just materializes whatever you need. So it is doable. And then you need some additional things inside of your test project, NuGet packages, for example. You will need to add the net test SDK, which is useful for doing the unit testing, and whatever extension you used in your bindings that you want to test. Be mindful. The big tip here is don't include the Microsoft Net SDK functions, the one that we saw a bit before that did all the attribute parsing into the JSON files. Because if you include that into your test project, it will actually put the output somewhere else, and your unit test framework will not pick up on them. So leave that one out, drop to the extension level, and add every binding that you used, pick extensions.http or extensions.blobs. And then it's, if you want to run that, you need to use that run method and supply it with all the arguments. So there were arguments for input, there were arguments for output. In most cases, because all the parsing will be done for you, it's if you have blob or queue, it might actually just be a string. So there's no need for any faking. If it's a byte array, it's a byte array. So you don't need to do mocking or stubbing there. HTTP request message, if that comes in, it's designed to be used as a dummy. So you can just wire up whatever you need inside of your HTTP request message. And similarly for your response. And then there's the trace writer, the object that we got. But you can subclass it and then do a different implementation there. Or you can use something different from the trace writer because it's not documented in all places, but you can just specify an iLogger interface and it will be injected the some logger implementation for you. Let's have a quick look at that as well. So this is a unit test project, and in this case we're trying to do the dump headers function test. I need to have to call the run method right here. The run method, it requires the request message and the logger that we need. So for the logger, I created this mock trace writer, which is just a subclass thing derived from trace writer. It overrides the trade method, and whatever trace event comes in, it stores into this local thing, so I could inspect it inside of my asserts. And in the dump header function, or the other thing that we need to do is create the fake request. So we'll create a request here. We need to set some headers. We could set some headers just to see them pop up. And we need to set some configurations. If you forget about this, then it will actually say when you run it that it needs a configuration and it's not set. So all you need to do is just create this HTTP configuration and set it on your request. And then you just go along and exercise your run method. That's it. It generates a response, and that's the object of your interest. That's what you want to inspect. So you would actually want to show the headers that go in to come out again. Simple thing. With the high scores, it's almost the same, except that it actually specifies this post method that we needed. It specifies the content, so it's string content here with a bad score. It's application JSON as a content type. You can specify that, and then we run it again. Since it's async, we need to do await. We need to do an await. An async test method as well. So we do async task at the top. And then it should actually say that this is a bad response because it receives a bad score and it should be a number. And here we just make sure that the output body of the response is also what we expect it to be. So you can test whatever is needed. All the other things that might go on inside of your run method, extract as much as possible so there's less testing. It's just input and output behaviors if you want to test that. Okay. Then the final part, the build scenarios. So if you want to move to production, you have your code. We have it in our Visual Studio. And how would you get it out there? Well, since this is compilable code, it's not the script version. That was option number 1. We need to build it, and we need a pipeline for it ideally. You can build it locally and publish it locally because there's the tooling from the command line interface. You can even use publish from Visual Studio, but sometimes we say friends don't let friends use publish from Visual Studio because that's like this developer thing. It's good for testing, but not for going to production. And then you would want to have something in VSTS or Jira, Jenkins, the combination that you want to use. Just as long as you can build a pipeline that includes as much as using NuGet, restoring all of the packages, building your solution with all the source code. And since the Microsoft Net SDK functions thing is in there, it will generate the right output. That's a package that you can just X-copy to your machine, to your Azure application. You run your tests, and finally you just publish whatever was created there. It will generate a zip file with all the content zipped together, and that's good enough to do that. If you want to release from here as well, sorry, I should say deploy from here as well, it's a matter of opinion if you want to do that in your release pipeline, the deploying, or that you just use release to swap slots or going from pre-production to production. If you change that, there's a comment there that you need to change how you deploy it. But the deployment itself is just an Azure App Service deploy task, since it's running an Azure App Service underneath. Well, then that is pretty easy. We will just push everything out into production, but it doesn't have all of the settings file that you need. We use development storage equals true. That's not something that you can use in Azure. So in this case, you need to manually create them there because your application is long-lived, or you can just push them out from locally with your command line interface. Whatever settings you have, and we saw the one at the right, you can use those settings and have them published as well. They can be encrypted because there's a flag, and you can encrypt them from the command line interface. If you need access to any of the values that are in there, like key 1 with its value, you can just do the environment variables call, and it will get it to you. And if you remember the curlies that we used inside of the attributes with Q-trigger, for example, you can even use percentage signs in the name of your setting, and it will also automatically put those in. So those are the values over there. You also have a separate section for connection strings, and your functions command line interface can interact with all of them. So for the final part, let's go to here. This is VSTS. I've created this build pipeline, going there. You can see the builds that I've done. Some of them have succeeded. If you go into a particular build, since we had the unit tests that we could run, we've also run them here in the part of the pipeline, so you can see your test results just like any of your other code. So it doesn't have to be very different. And then the releases, we didn't see that yet. We saw the build pipeline in the slides, but your release is actually, you can add as many environments as you want. There's a preview thing in Azure Functions that's called slots. It's down here. The slots preview, which allows you to publish to a pre-production slot, so you can test it there, call it staging, and then you can just swap them around and you go from staging to production. That's your new version. So that's one thing that you can do, but inside of your production environment or your pre-production, there's a phase, and it's just a matter of, this is the simplest one that you can do. But you can do whatever you need with all of the tasks to deploy your application. But this is just the basis of it, and it specifies that you need to use the zip file, and it says that it will actually go to this app service name that should exist. If you want to create the app service yourself, I suggest that you look into ARM templates, because ARM templates allow you to a reproducible way to provision your app service and your functions, and then you just need to deploy on top of it. Hosting options, final bit. We talked about the consumption-based part where it just scales as needed, but you start from low capacity and reach out. but you can go on. If you host them in Azure, it's actually easy to combine it with all of the Azure resources available. Especially look into logic apps, because logic apps do this workflow, this orchestration, where they can call out to other pieces of functionality, which can be your Azure Functions. And then the on-premises version, you can install whatever is running underneath the Azure Functions runtime. You can install that onto machines, point to a database, and it ties it all together, and you have your own version of Azure Functions running on premises. Might be necessary in case of legislation or other restrictions that you might have, so you can do it. But it moves away from the serverless because you actually have to take care of all those machines that are running there. There we go. And if you run into production, then you would want to know what is happening inside of your application. So you can do the monitoring that's inside of the portal. You can see the monitoring that arrives in your logs. But if you want to take it to the next level, you should look into application insights. Because if you turn that on, it's as simple as adding a setting in your host JSON that's called application insights instrumentation key. Application Insights allows you to just dig really deep into the performance characteristics of all the errors that are happening, the completed successes, and you can change your host JSON file to tweak the sample rate on which this is happening. And this allows you to even query all of the events inside of your output from the App Insights. Azure Functions will start doing that by itself, and you can put in client telemetry yourself, so you can even build out application maps in Application Insights. Do look into that. Okay. Azure Functions with .NET Core 2 is coming. It's currently in beta, but they're working on it. It's all based on .NET Standard 2.0. You will need different tooling. So the Azure Core Tools 2.0, it's running on NPM, so you need NPM to install it, and it's Node.js for hosting locally, whereas the 1.0 version uses just this executable with it's a C# implementation. And if you run them side by side, make sure that you know which version you're running on, because in this case here, if we would run this, it will actually say version 1.0. That's the one we're using now for hosting. This can be 2.0, and it takes precedence over the 1.0 one. So do look into that. You can tweak it with this environment variable where you say, okay, I want to use the next version, the beta, or you can just use tilde1, and in a while it will be tilde2 if you want to use functions 2.0. There's all these best practices. I've mentioned most of them. Single responsibility, finish as quickly as possible. Make sure that whatever code you're executing, if it gets executed again, it doesn't do a bad thing. It just repeats or ignores. And you can use all this cross-function communication with underlying things depending on your message size and scenario. There's also durable functions, which is just chaining functions together in all these scenarios. That's also available, but in the end, I think that if you start looking into Azure Functions, there's all these ways to program it, but with .NET and what you know about .NET, I think there's a lot of marriage there. Thank you very much. Any questions? For now, we have 1 or 2 minutes, I think.
Yes, we have 2 minutes.
Yes, please.
I have one question. Currently, there are a lot of data centers around the world, but there is no data center in Russia. Any plans, to create data center in Russia, for example?
Okay.
I think this is the major reason why Windows Azure is not so popular in Russia.
Okay, so question, will there be a data center for Azure in Russia? That I do not know. I don't work at Microsoft or for Microsoft, so I do know that there's people out there, but I have no idea. Sorry about that.
Some words about strategy for function versioning. Let's say, because with keeping function very small, because then you have a potential challenge that you update a function and it changes its signature file format. Then how would you handle that if some functions become incompatible in the large system?
So the question, we have 1 minute left, so I'll try to be brief here, but we'll take it at the discussion zone as well. You can run them side by side because that goes really well. And there's all these strategies that you can also use. For example, maybe inspecting the request, look at a header that indicates a type of the version that you actually want to use in the API, and then work from there. But that's one thing that you can do. That's for HTTP triggered things, because that's just web API style versioning. If you do the same and it's serialization format into queues, you could build other functions that have a naming convention. The name doesn't really matter, but it just listens at different queues that have a different format expectation. And that's another way to keep them separated. You can use them side by side, and you can just move over from the old to the new version, and after a while throw away the old queue and start working with exclusively the new queue that expects the new format. So that's a short indication of where you could go with your versioning. Okay, thank you very much. And if you have any questions, I'll be at the discussion zone, number 2, and happy to answer any of your questions. Thank you.